Alright everyone, here we are again, going 6.3, so we're writing quadratic equations. So very similar to what we did in our previous unit, where we took different information and put it into the equations. And switched them around. Now what we're going to do is actually use this for like real life and also some different situations there. So just a refresher, we have our three forms: standard form, intercept form, and vertex form. The one nice thing about all three of these forms is it gives us our rate of change, or our A value, so rate of change, or I'm just going to abbreviate these and these other ones so I don't have to write it all out. ROC, rate of change. And each of these forms gave us something unique and that we could use to be able to write the equation. The standard form, the C was our y-intercept. Intercept form, the P and Q, as in the name of intercept form, are our x-intercepts. And then vertex form, the H and K gave us our vertex. Or H and then K. Just to kind of give you the other ones, so our y-intercept would be 0 and then C. X-intercepts would be P and then 0 and then Q and then 0. So those are those there. So knowing this, let's go ahead and give these problems a try. Let's write an equation that models from the given information. So here, a quadratic equation with x-intercepts at 2, 0, negative 2, 0, and that goes through a point. So we're given x-intercepts, so we're going to use our intercept form, where y equals a times x minus p times x minus q. So our intercepts are 2 and then negative 2. So we got to plug those in for P and Q. Doesn't matter the order. Remember, when you plug them in, you got to switch the sign. So once we plug them in, we're going to have y is equal to a times x minus 2, because we changed the positive 2 to a negative 2. And then we'd have x plus 2, because we changed the negative 2 to a positive 2. But now, guys, to be able to get our final equation, we got to solve for a, and that's where this point here comes into play, a point at 0, 4. So 0 would be the x value of that, 4 is the y. So what we got to do is plug those in to our equation that we just made, and then solve for a. So anytime we see y, we're going to plug in a 4. So we'd have 4 is equal to a times, and now x, so we plug in 0, minus 2, times 0, plus 2. And now we just crunch our numbers and see what we get. So 4 is equal to a times 0 minus 2 is negative 2. 0 plus 2 is 2. Okay, now we need to multiply these two. So we get 4 is equal to negative 2 times 2 is negative 4. So we're going to have a times negative 4. Or that's going to be the same. I'm going to come over here as 4 is equal to negative 4 over a. Now we want to solve for a, so we divide by negative 4. Divide by negative 4. So 4 divided by 4 is 1, but since we got a negative, we're going to have negative 1, and that's equal to our a. Now that we have our a, we can plug it back into our original equation right there. So then our equation for this would be y is equal to negative 1 times x minus 2 times x plus 2. And that's how we do that if we're given the x-intercepts, So we'd pull basically the exact same thing if we had for b here. So we'd make our equation. We'd have y is equal to a times x plus 2 because it's negative, and then times x minus 4 because it's positive, and then we'd plug in 2 for x and 4 for y. Okay, I'll leave that to you guys to see if you can figure that one out. What we are going to do is we're going to look at another example where we're given the vertex and then a point. So for vertex, we're going to use vertex form, which we can look at the top of our paper as y is equal to a times x minus h squared plus k. So in our vertex, our x value is our h, and our y value is our k. So if we're plugging anything into the parentheses, so plugging our h in, we got to flip the sign. So if we plug that in, we're going to have y is equal to a times x. It's positive 1, so it's going to be minus 1 squared. And then we're going to have positive 6 plus 6. Now we got to plug in our point. So we plug in 2 for x, 4 for y. And so then our answer for y, we'd have 4 is equal to a. And then we'd have x is 2 minus 1 squared plus 6. To simplify this, so 4 is equal to a times 2 minus 1 is 1 squared plus 6. 1 squared is 1, so we'd have 4 is equal to a times 1 plus 6. Anything times itself is just itself, so we'd have 4 is equal to a plus 6. I'm going to bring that over to the top right there. So we'd have 4 is equal to a plus 6. Now we want to move that 6, so we subtract it from both sides. 4 minus 6 is negative 2 is equal to our a. So we got our a in our original. Plug our equation in, so we get y is equal to negative 2 times x minus 1 squared plus 6. That would be our answer. So we're going to follow that same process. Not a lot of room for this one, but we plug in our numbers. So we'd have y is equal to a times x. Again, negative 4 is our h, so we'd have x plus 4 because we got to switch the signs. And then we have minus 8, and we'd solve that by plugging in 2 for x, or negative 2 for x, and negative 5 for y. While you guys work on that one, I'll finish up B here, so that way you can check your answers. So here we have 4 a times 2 plus 2 times 2 4. So that's the answer for B there. You're still working on D, that's fine. So we want to make a list of how to write a quadratic expression using key features. So first, we need to identify which equation to use. Identify which equation to use, and we do that based off the key features. So if it gives us our vertex, like in number 2 down here, then we use vertex form. If it gives us our x-intercept, like in B here, then we use our intercept form. So then 2, we got to plug in our key feature. Okay, and then they also need to give us a point, like both of these ones do. So then 2, or number 3, we got to plug in our point. And lastly, number 4, we got to solve for A and then plug in that into our equation. Okay, so first we identify which equation based off the key features, based off of what it gives us. If it gives us our y-intercept, or not our y-intercept, if it gives us our x-intercept, then we use x-intercepts. If it gives us our y-intercept, then we use our y-intercept. Or again, why am I saying y-intercept? If it gives us our vertex, then we use our vertex form. It may give you your y-intercept, probably won't, but you may see that. Then we plug in whatever key feature it is, plug in the point, solve for our A, and then plug it into the equation. Some tips here, it might be helpful to label our key features. As well as our x and y. So meaning by that, if this is our vertex, 3 would be our h, 12 would be our k, -1 would be our x, 53 would be our y. For B down here, we could say 6 is our p, 10 is our q, then 2 is our x, and 3 is our y. Then remember, when plugging in the key features and only key features, we got to switch our signs in parentheses. Okay, so that's how we do those. For this one here, guys, just want to give you the answers. That way you can do them on your own and check. So this, you'll get y is equal to, let me see here, 41 over 16 times x minus 3 squared plus 12. See if you can get that answer. And then for this one, we'll get y is equal to -7/16 times x minus 6 times x minus 10. Okay, see if you can get those answers. And as always, reach out to me or whoever teacher you have for if you have any questions.